Hello, my year 12. Today we'll be doing Venn diagram and probability. So, as you have seen before, Venn diagram is something like this. And we're going to use this to solve some probability questions. So, to start today, I need to introduce or reintroduce the idea about mutually exclusive events. Mutually exclusive events are those without any common elements. In other words, if one event happens, the other doesn't. Which means it's either or. And the word or in probability means plus. So, for example, in this case, if a card is drawn at random from a center pack again, find the probability that it is a red card or a spade. Here is the thing. A red card cannot be a spade because a spade is a black card. In other words, these events to be a red card and a spade, these two cannot happen at the same time. In other words, they are mutually exclusive. In this case, if we're using the Venn diagram to generate it, they have no common elements. This is being red, this is spade. Alright, so in this case, how many red card? 26. 13 spade card. Therefore, the probability of red or spade will become probability of red plus the probability of spade. Therefore, in this case, that is 26 over 52, which is half obviously. That is 13 over 52, half plus a quarter, 3/4. So in other words, if two events are mutually exclusive, if events A and events excuse me, events B are mutually exclusive, then the probability of A or B is equals to the probability of A plus probability of B. So that is basically the rule if two events are mutually exclusive. What happens if the two events are not mutually exclusive? In other words, there are some common parts in between these two events. Event B are not mutually exclusive. Then, now this is the very, very famous addition rule. That is, the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. How does that work? If we imagine a Venn diagram, A and B. So if I want to find out A or B, that means I want everything in here, basically. But how do you actually get this everything? So that is all the red in here. Oh, why doesn't give me the red one? Yes, it does. All the red one in here plus all the blue one in here. But if you just add up these two, which is A plus B, you have add up the middle part twice. In other words, the middle part here, the green one, that is A and B at the same time, simultaneously. Therefore, if you add up individual A or B, you need to take away the common part because you have added up twice. Okay? All right. So let's take a look at an example that use this kind of idea. Because sometimes you have to work it out what's in the middle. So in a class of 30 girls, so in this Venn diagram, including the outside bit, there are 30. 13 play tennis, 23 play netball, 7 girls play both. What is the probability that a girl chosen at random plays neither sport? Which means you need to find out the number outside. So in this particular case, now think about how we can actually construct this. The most important bit in here is to recognize the number of girls that actually play tennis includes those actually play both. The number of girls that play netball also includes the girls that play both. So in other words, if you have 13, the 13 is not right here because whatever right here represent the girls that only play tennis, and whatever right here represent the girls that only play netball. So to deal with a Venn diagram, we always start with the middle number, 7. So in this particular case, if I know there's 7 in the middle, there are 13 girls that play tennis, and that includes the 7. So therefore, there should be 6 in here, because 6 for 7 is 13. And for the same reason, if the 7 girls play both, the 23 play netball, that includes the 7, therefore there should be 16 right here. That's how you add up the numbers. Otherwise, if you add up 13 plus 23, that's already over 30. That doesn't make sense. Okay, so therefore, if you 6 plus 7 plus 16, you get 29. So if there are 29, therefore only one student is left over. So therefore the probability of playing neither sport is just 29, also 1 over 30 in this case. However, what is the best way of doing this? Because if we are finding the probability of playing neither sport, that basically is 1 minus the probability of playing either sport. Either tennis or netball. Either or, which is the whole bit right here. And to work out that bit, that is 1 minus the probability of tennis plus the probability of netball minus the probability of tennis and netball. Using our addition rule, that means that is, what do you have? 13 plus 23 minus 7. Everything is every single one. Sorry, I need to rewrite this. 13 over 30 plus 23 over 30 minus 7 over 30, which is 1 minus 29 on 30. That will give you 1 on 30. Okay, so this is how we use the so-called addition rule in probability. Okay, so remember, the probability of A or B is probability of A plus probability of B minus probability of A and B, which is the middle part, because you have over adding it. Alright, let's take a look how we can use this addition rule to simplify or solve a question with complementary events. Again, now, a card is drawn at random from a pack. Find the probability that it is not an ace or not a 2. So it's neither nor, basically. Not an 8, nor a 2. Okay, so for first of all, we need to find out what is the probability of ace or 2. Okay, so but however, in this case, for part A, does this 2 circle actually intersect? They don't, because ace and 2, they're 2 different numbers. There's no card can be ace and 2 at the same time. So therefore, for part A, the probability of ace or 2 will simply just be 4 plus 4 over 52. That is 2 on 13. And therefore, the probability of not an ace and not a 2 equals 1 minus 2 over 13. That is 11 over 13. Obviously, basically just any of the 11 number card, including Jack, Queen, and King, of course. Alright, so last part in today. Find the probability that it is an even number or a picture card or red. Now, in this case, it's a little bit more complicated. So what we're trying to find out is the probability that it's an even number or a picture card or red. So the complementary is easier to find out in this case, in fact, because there are less cases. So in other words, the probability of that is even or picture or red, that should be equals to the probability 1 minus the probability of, what is that? That is odd or number or black. Okay? Oh, I should be at the same time, which is and, not or, because it's 1 minus. So how many of them in this case? Basically, it's just 1, 3, 5, 7, 9. In both spade and club. Because odd number card and black. In other words, that is 10 out of 52. That is 1 minus 5 on 26. That is 21 on 26. Okay? Right, so this is how we use Venn diagram to actually solve some of the issue. I'll explain more of these questions when I come back next week. And I would like you to start with exercise 8D today. Right, I'll see you next Monday.